Do you want me to go over 16 too? Okay, shh, stop talking, I'm starting. Okay, our goal is to solve, which means get the variable by itself. Well, we have a variable on both sides. This one's by itself, but this one's not. What can we do to get it by itself? Square it, because you cannot remove anything from up underneath the radical until the radical's gone. And the inverse operation of a square root is squared. It cancels out. But if you square that side, you must square this side. So now on the left we have a squared, and on the right we have 6 minus a. Okay, so what we're left with is 3 different terms. You have an a squared, a constant that has no a at all, and an a to the first. When all 3 terms are different, what do you have to do? Correct. Move them all to the same side, set it equal to 0. So a squared will stay. How do we move this negative a over? Add it. And how do you move the 6 over? Subtract it. So when they're on the same side, these 2 that had to move will just be the opposite sign of what they were. Now when it looks like this, a lot of people, I bet, get confused right here because you know you need to factor, but you get confused about the numbers you're looking for. Did you keep in mind that this is a 1? Okay, anytime you have a variable and there's not a visible coefficient, it's always a 1. So we're adding to 1 and multiplying to negative 6. What numbers will add up to 1 and also multiply to negative 6? Positive 3 and negative 2, right. Because 3 plus a negative 2 is 1. 3 times a negative 2 is negative 6. So that means our final answers will be what and what? Negative 3 and positive 2. Once you have your answers, what do you have to do? You have to check them. And what are we looking for? Why are we checking them? Right, both. We're seeing if it works, and if it doesn't work, it's called an extraneous solution, and you'll have to identify that on the test. Okay, so first let's start by doing the negative 3. If I put a negative 3 on this side, and I put a negative 3 in this side, in the a places, type in this, the square root of 6 minus negative 3. Right, when you type in a 6 minus and then a negative 3 in the a place and you hit enter, you get a positive 3, and it was supposed to equal a negative 3. So what do we call this negative 3? It's an extraneous solution. Okay, now let's try it with the 2. If I replace both a's with a 2, we could probably do this one without the calculator. What's 6 minus 2? And what's the square root of 4? 2. So that one was okay. So that's your only solution. A equals 2. The other one is extraneous. Okay, any questions about that one? Okay, now let's look at number 18. We're trying to get x by itself. This one is not by itself, so what can you do? Well, it's already square root. Square it. And if you square one side, you must square the other side, right? On this side, they cancel each other out, leaving x equal to x squared. Now, for some of you, it might go ahead, you might benefit yourself by going ahead and putting a 1 right there. And you can put a 1 right here if you want. But really, this one will help you the most. Now, what should I do? Correct. So to set it equal to 0, what should we move? Okay, where should we move it? To this side? And how would you move it over there? By subtracting it over. So now I want it to be equal 0, but I'm just going to put equal 0 over there because I just prefer that. Now what can we do? Okay, let me show you something. For those of you who struggle with factoring, you have an alternative way to get the answer. Watch, you'll like it. If you now go to y equals, and you just type that in, x squared minus 1x, and you hit graph, where do you see that parabola across the x-axis? 0 and 1. So 0 and 1 are your final solutions. Now let me show you how you would have got that if you'd have continued factoring. You would have had to factor this one by GCF because it's only a binomial. So you would have taken out the x, and when you take out an x, it leaves x minus 1, right? Well, you would have set that x equal to 0, and you would have got that one. When you set x minus 1 to 0, when you had to added 1, and that's how it became a positive 1. But if you don't like factoring, once you get to this step, graph it and see where it crosses the x-axis, and those will be your solutions. Now, you still have to check them to make sure you're not dealing with an extraneous solution. So first, let's start by checking the 0. If I plug in a 0 here and a 0 here, does that make a true statement? Is the square root of 0 equal to 0? Yes. So this one's good. And now let's check the number 1 in both of them. If I plug in a square root of 1, does that equal 1? Yes. So both of them are good. We don't have any extraneous. Okay, now what I'm going to do is, on page 13, I'm just going to go ahead and write the final answers for 8, 10, and 12. Then that way you can check them to make sure you got the right answer. A equals 2. B equals 1. And this one had 2 solutions because you ended up having to square that b to get rid of the square root. And so b equals 6. And neither one of them were extraneous. Do you have any questions about those 3? Both of them were positive. Because your factors, when you had to factor it, you ended up with b minus 7, b minus 6. So both of them became positive. Okay, now turn to page 14. And I will write down the answers for 20 through 26 even, and you can check to make sure you got those right. Okay, number 20, you should have ended up with 2 solutions, x equals 9, x equals 1. And neither one of them were extraneous. For number 22, n equals negative 10, and n equals 9. But the negative 10 was extraneous. When plugged in, it produced a positive 10 on this side instead of another negative 10, so that's an extraneous solution. Okay, and then number 24, 2 solutions again for this one. N equals 0, n equals 9. And both of them worked when plugged in. And then for 26, n equals 0, n equals 3. Any questions on that page? We're moving on to the most difficult kind today. Okay, page 15. What?
I went home and I showed my grandma.
Page 15, here we go. Now, to be honest, nothing that I'm about to do is new math for you. Like, everything I'm about to do, you've done before. It's just combining it all in the same problem. So if you'd like, you can just watch me do the first one, and then I'll give you time to copy it. That way you don't miss steps when you're looking down copying, okay? All right. So we have b minus 4 on this side, and we have 7b minus 40 on this side. Our goal is to get b by itself, but currently we have a b on this side with a minus 4, and a b on this side with a lot of stuff. The first thing you need to take care of is this square root. Get rid of it by squaring it. But look, when you come to this side to square it, there's 2 things over there. So you're squaring both of them, and you show that by putting it in parentheses. Okay, so now what I have is this is canceled out, and over here, b minus 4 squared, doesn't that mean there's 2 of those? You multiply it by itself. And then on the right side, those canceled out, so I'm left with 7b minus 40. Okay, go ahead and copy that, and then I'll continue. Well, we're about to. We're about to FOIL it. Oh, no. That's not the same thing. So just watch again, and I'll give you time to copy. The next thing we're going to do is we're going to actually multiply those together. And you multiply 2 binomials by FOIL, or some people just like to call it distributing. b times b is b squared. b times negative 4 is negative 4b. Then you have to do the negative 4 times b, and you get negative 4b. And negative 4 times negative 4 is positive 16. See, that's nothing new. You've been doing that since probably middle school. On this side, we still haven't dealt with the 7b minus 40. And we're not going to yet, because can't we do one more thing to this side? What else can we do over there? Right. B squared minus 8b plus 16 equals 7b minus 40. Well, write it smaller. Take the scratch paper. Okay. So now I'm going to combine like terms. Can't I move this over to this side by subtracting 7b on both sides? And I can move the 40 over by adding 40 here and adding 40 to the 16. And so now I have b squared. That makes minus 15b. That makes 56. And now on the right side, it's 0. So from here to here was the new stuff. Now this is just like yesterday. Now I'm just going to factor by looking for two numbers that multiply to 56 and add to negative 15. What two numbers will do that? Okay, but to add up to a negative and multiply to a positive, they both need to be negative. And so your final solutions are positive 8, positive 7. Right? Now remember, if you don't like factoring, this is what you could have done. If you could at least have made it to this step, you could graph that. But I don't use b, we use x when we graph. So x squared minus 15x plus 56. When I graph it, I see a parabola that crosses the x-axis in two places. And it looks like those two places are 7 and 8, which were my final solutions. So technically, you could skip the factoring step every time if you're not good at factoring, and just graph this and find the two x-intercepts, and those are your solutions. Now, you still have to check them to make sure that you're not dealing with an extraneous. So go ahead and finish copying, and then we'll check them. Not always. Okay, now let's check them. Starting with the 8. If I plug in an 8 on this side and an 8 right here, that becomes 8 minus 4, which is 4. And then over here, that becomes 56 minus 40, which is 16. And then the square root of 16 equals 4. So 8's good, it worked. Now let's plug in 7 to make sure it works. If I plug in a 7 over here, 7 minus 4 becomes a 3. If I plug in a 7 over here, 7 times 7 is 49. 49 minus 40 is 9, and then the square root of 9 equals 3. So both of them work. Neither one of them are extraneous. Any questions? Do you see, though, how nothing we did is new material for you? It's just combining it all? I didn't have time. Okay, can I erase? Yeah. Okay, let me erase and we'll do number 3 together. Okay, number 3. The first thing that I need to do is get rid of this square root. To get rid of it, I square it. Okay, and that leaves just 20 minus 2a. But since I squared this side, I must square this side. Well, there's two things over there, so you're squaring it all. A minus 10 squared literally means a minus 10 times a minus 10. Flip-flopping? That's fine. No, that's fine. Okay, so now I have 20 minus 2a on this side, and you can't combine those. They're not like terms. On this side, I can now distribute or FOIL, whatever you want to call it. A times a is a squared. A times negative 10 is negative 10a. Negative 10 times a is another negative 10a, and negative 10 times negative 10 is positive 100. Any questions so far? Yeah, like you having to distribute the a to both of those and then the negative 10 to both of those, so that's why you end up with 4 terms. Okay, but now I can take those terms and combine them some more, because the negative 10a minus 10a will combine to negative 20a. And now what should I do? Put them on the same side, right? Like, can't I add this 2a to cancel it on this side, but then I add it over here to the 20a? And then I can subtract the 20 over here to cancel it, but then I have to subtract it from the 100. And so now I have a squared, negative 20a plus 2a is negative 18a, and then 100 minus 20 is 80. And then you can put equals 0 over here, because technically it all canceled on the left, but I always like to just put equals 0 at the end. So now, like I said before, if you don't like factoring, like if you struggle thinking of the numbers that multiply to 80 and add to negative 18, what can you do at this point? Just graph it. Type in y equals x squared minus 18x plus 80, and where it crosses the x-axis are your two solutions. But if you're okay with factoring, you can do the bubble method. What numbers multiply to 80 and add to negative 18? Negative 8 and negative 10. And so the final solutions are positive 8 and positive 10. And where would the graph, like if you'd have graphed this, where would the parabola have crossed the x-axis? 8 and 10. Okay, now just like always, we have to check them to make sure they're not extraneous. So I'll start by checking the 8. If I plug in an 8 right here beside the 2, isn't that going to make a 16? And 20 minus 16 is 4, and the square root of 4 is 2. If I plug in 8 over here, 8 minus 10 is negative 2. So look, I don't end up with a true statement, so that 8 is extraneous. And see how it wasn't negative? Sometimes even positive solutions can end up being extraneous answers. Now let's try 10. Okay, if I plug in 10 on this side, what's 2 times 10? 20. And if I plug in 10 on this side, I get 10 minus 10, which is 0. 20 minus 20 is 0, and the square root of 0 is 0, so it works. Okay, let's try number 5, and then I'll let you try 7 by yourself. Is anybody still copying? We're good? Okay, number 5. Look at this one. It's a little bit different. What do you think I need to do first? Right. That 7 is not trapped up under the square root sign, so we can go ahead and move it by subtracting it. And so now we have the square root of 25 minus 4x on the left, and on the right we have x minus 7. And now it looks like the problems we've been working. So what should I do first? Square it to get rid of the square root, and then I square this side, but since there's more than one thing, you put it in parentheses to show that you're squaring it all. So now I have 25 minus 4x equals x minus 7 squared, which literally means x minus 7 times x minus 7. And now what can I do with that? FOIL it. X times x is x squared. X times negative 7 is negative 7x. Then you have to distribute this negative 7 times both. Negative 7 times x is negative 7x, and negative 7 times negative 7 is positive 49. And then on this side, we haven't done anything yet. Okay, now before I still don't do anything to that side, because I can still finish simplifying the right side of the equation. What can I do over there? Right, so it'll become x squared, then what? Okay, Derek, now what can I do? Okay, anybody? Okay, remember we have a quiz on Friday. And then I can subtract 25. And so now those all cancel out. So I end up with x squared. That becomes a negative 10x. And then that becomes a 24. Now at this point, you could just stop, graph it, look for the two x-intercepts, and those are your solutions. Or you can just continue by factoring, looking for two numbers that multiply to 24, add to negative 10, and what numbers do that? Negative 6 and negative 4. So that means that if you had graphed it, it would have crossed the x-axis in what places? Positive 6, positive 4. Okay, now let's check it to see if we're dealing with an extraneous solution. Okay, watch, because this one's different. Okay, everybody watch me check it. First, I'm going to plug in 6. If I plug in a 6 right here, what does this become? 24. And then I'll plug in a 6 over here. What's 25 minus 24? What's the square root of 1? And what's 1 plus 7? 8. So that did not work out, did it? So that's an extraneous solution. Now watch when I plug in 4. If I plug in a 4 into both x's, what will this become if I put a 4 right beside that 4? 16. What's 25 minus 16? And then the square root of 9 is? And 3 plus 7 is 10. They're both extraneous. Let me show you why. Okay, I'm going to show you why. Watch the calculator. No. I mean, yes, there is, but I'm about to show you. Watch. Okay, everybody watch. I am going to graph the original function, the radical function. Okay, you watching? Y equals the square root of 25 minus 4x, and then on the outside plus 7, but then this x is on the wrong side, so I would have to subtract it over, so minus x, and now watch when I graph this. It never hits the x-intercept, or x-axis, does it? That's why neither solution worked. Okay, now let's go back and look at that with the previous one. What were the solutions for number 3? 10 and 8, but 8 was extraneous. Okay, so let's look at this. Okay, shh. The first thing you should have done is added this x over.
I did not do that.
Okay, anything outside the radical can go ahead and be moved. It's not trapped up under. So now you have 2 plus x equals the square root of 2x plus 3. Okay, now the problem pretty much looks like all the other ones. There is a minor difference. Shh, pay attention, please. You have to square this side to cancel out the square root, and then you have to square everything on this side. So that becomes 2 plus x times 2 plus x. And then on this side, it's just 2x plus 3. So now, like always, you're going to FOIL. Things are just a little out of order. 2 times 2 is 4. 2 times x is 2x. X times 2 is 2x. And x times x is x squared. Any questions so far? Do you know how you could have avoided that happening, like where it's all backwards? At the very beginning, when you got 2 plus x, couldn't you have just quickly rewritten that as x plus 2? It's the same thing. 2 plus x plus 2, it's the same thing. It's called the commutative property. You can add in any order. So, like at the beginning, if you see something like that, you can just flip-flop the x and the 2, and then it'll end up nicely, like x squared plus 2x plus 2x plus 4. Okay, so now, look, this becomes, let's just go ahead and rearrange it now. We'll put the x squared up front, the two x's combine to 4x, and then 4 goes on the end. You're not paying attention. You got to pay attention. I said I'm just going to go ahead and fix this. Since it's out of order, I just went ahead and threw the x squared up front. Oh, look, x times x. Okay, so now I'm going to subtract the 2x, and I'm going to subtract the 2x. I'm going to subtract 3 and subtract 3. So now I have x squared plus 2x plus 1 equals 0. Now okay, now watch. What numbers multiply to 1 and add to 2? 1 and 1. So technically, you really only have one solution for this one, and it's -1, right? Okay, now let's check and make sure it's not extraneous. Yeah, that's called standard form, where you have x squared, x to the first, and then your constant. Shh. Okay, -1 will be plugged in both x's, but look, that's already got a negative. So a negative, and then a -1 plugged in, won't that become a +1 right there? And then if you plug in a -1 right here by the 2, that becomes a -2 plus 3, which is 1. And what's the square root of 1? So look what we end up with. 1 plus 1, which equals 2. So that one works. Okay, I'm tired of talking over some of you, so you finish 9 and 11 for homework. Okay?